Hey guys, Mr. Black here. Today we're going to be talking about Newton's laws of motion. There's 3 of them. They're really exciting. I know you guys were excited about learning about the different types of forces, but now we're going to learn about Newton's laws that has to do with those forces, which I think is even more exciting. So let's go ahead and get started. So there are 3 laws, like I said before. The first one is all about inertia. So an object at rest is going to stay at rest. An object in motion is going to stay in motion. We've all heard it before, but I really want to kind of get a better understanding of what that means, what inertia is, which we'll talk about as we go on. Newton's second law is, the force equals mass times acceleration. So what is that? That's a formula, but we're going to dig deeper into that, what that means as well. And then the third law, for every action, there's an equal and opposite reaction. So we're going to look into what that means as well, because we've all heard these before, but not everybody knows exactly what these things mean. So let's check it out. So when we're looking at Newton's first law of motion, this is what we call the law of inertia. So as an object's mass increases, so too will its inertia. Okay, and inertia is basically, if you're wondering what that means, inertia is the tendency of an object to resist changes in its velocity, whether it's in motion or motionless. Okay, an object that's sitting there does not want to move, right? And so it's going to take force to be able to move it. And the bigger an object's mass is, the more difficult it's going to be to move that object. So if we were looking at, let's say, a golf ball, for instance, once that golf ball is airborne, unless some kind of unbalanced force is acting on it, let's call it gravity or air resistance, anything like that, if those things weren't acting on that ball, it's going to go on forever. There's nothing stopping it, right? Because of inertia. It doesn't want to stop. An object in motion wants to stay in motion. But because we have things like gravity and air resistance, things like that, it does end up stopping. So again, unless acted on by an unbalanced force, the golf ball is going to sit in the tee forever in this case. So we've got gravity pushing down on the tee. We've got the tee pushing back up on the golf ball. And so it's going to be staying in that exact same spot. It doesn't want to move. An object at rest wants to stay at rest. All right, now let's look at the second law of motion. This is all about the equation force equals mass times acceleration. So what does that mean? Well, the net force of an object is equal to the product of its mass and acceleration. Okay, so an object has a certain amount of mass and an object has a certain amount of acceleration. As an object's mass increases, so too is its net force, right? Same thing with acceleration. As an object's acceleration increases, so too will its net force. As an object's net force decreases, we're probably going to be seeing a decrease in either mass or acceleration of an object, or maybe even both, right? So these have a direct relationship with one another. So when we're looking at the second law of motion, when mass is in kilograms and acceleration is in meters per second squared, the unit of force is in newtons. So this is something that we talked about before. 1 newton is equal to the force required to accelerate 1 kilogram of mass at 1 meters per second squared. Alright, so here we've got a couple of problems. I know it's kind of hard to see, but in this first one it's asking how much force is needed to accelerate a 1,400 kilogram car 2 meters per second squared. So we've got mass is 1,400 kilograms and acceleration is 2 meters per second squared. We'd multiply those two together, and what we'd end up with is our force being 2,800 newtons, right? So it's our mass times our acceleration. Something that I think is really interesting when we're looking at Newton's second law is that it proves that with different masses of objects accelerate to the Earth with the same rate, right? Everything falls to Earth with the same rate, but they have different forces. So what that means is an object that has a larger mass that's falling, right, compared to an object that has a smaller mass, they're both accelerating at the same amount, but because this thing has so much more mass, the amount of force that it's bringing down is much greater, right? That's why if a pebble knocks you on the head, not going to be a big deal. Maybe you have a little goose egg up there, but if you get a boulder fall on your head, it's creating a lot more force, and that's going to cause a lot more damage, right? So that's something that we have to think about when we're looking at Newton's second law. Um, However, because of the second law, we know that they don't hit the ground with the same amount of force, right? So that's something that we will know because, like we said, this one's going to have a lot more force than this one.